All right, let's take a look at question number 9. So for question 9, we have to find the average rate of change of the function f of x equals cosecant x on the interval pi over 6 to pi over 4. All right, so before we go ahead and solve the problem, let's take a look at the formula for average rate of change. So um, the average rate of change formula, the average rate of change formula, let's write it down. So the average rate of change of f of x on an interval AB can be given by f of b minus f of a, that entire thing divided by b minus a. Okay, so that's the formula for the average rate of change. And also some other pieces of information you need to know involves finding the sine, cosine, tangent, cosecant, secant, and cotangent of your common angles. So I'm just going to go over a few. You want to remember that sine pi over 6 is equal to cosine pi over 3, and that's equal to 1/2. You want to remember that sine pi over 4 is equal to cosine pi over 4, and they're both equal to root 2 over 2. And last but not the least, um, sine pi over 3 is equal to cosine pi over 6, and that's equal to root 3 over 2. Okay? All right, now these are the ones that are applicable to this problem that we're working on right now. There are other ones that you need to have memorized, but I just want to highlight these, okay? So let's go ahead and solve this problem. We just need the function a and b, okay? So the function f of x is cosecant x, and using our reciprocal identities, we know that this is equal to sine x, okay? And then since our interval is from pi over 6 to pi over 4, that this follows that a is equal to pi over 6 and b is equal to pi over 4. All right, now let's go ahead and compute the average rate of change. So the average ROC, rate of change, on the interval a, actually the interval is pi over 6, 4, pi over 6 to pi over 4. Another way I like to write average rate of change is delta f, delta x, on the interval pi over 6 to pi over 4. They mean the same thing, I just like to use different notation. So we're going to go compute f of pi over 4. This is f of b minus f of a, f of pi over 6, divided by b minus a, pi over 4 minus pi over 6. Okay? Now we're going to evaluate this function, input these input values into our function cosecant x. So what we're looking for is cosecant pi over 4 minus cosecant pi over 6, and these divided by pi over 4 minus pi over 6. All right, so let's compute cosecant pi over 4 and cosecant pi over 6. Let's do that on the side here. I know that cosecant pi over 4 is equal to 1 over sine pi over 4. And then I know that sine pi over 4 is root 2 over 2, so this is going to be 1 over root 2 over 2, which is equal to 2 over root 2. All right, so that's the value of cosecant pi over 4. Let's take a look at cosecant pi over 6. Cosecant pi over 6 is 1 over sine pi over 6. And we know that sine pi over 6 is 1/2, so it's going to be 1 over 1/2, which is equal to 2 when I multiply 1 by the reciprocal of 1/2, which is 2 over 1. All right, so before I input this, let me quickly rationalize the cosecant pi over 4 since it has a radical in the denominator. So if I rationalize this expression, root 2, I'll end up with root 2 because I'll have 2 root 2 over 2 and the 2's cancel out, so we have root 2. Okay, we're good to go. So now we're going to have cosecant pi over 4 will have the value of root 2. That minus cosecant pi over 6 is just 2. And we're going to divide that by pi over 4 minus pi over 6. We can find the LCD. LCD is 12, so multiply this by 3 top and bottom. And this one we can multiply by 2 top and bottom. So what are we going to have? We'll have 3 pi minus 2 pi. 3 pi minus 2 pi is just simply pi. So we have pi over 12. And then if we multiply the numerator by the reciprocal of the denominator, we're going to have 12 root 2 minus 2 divided by pi. All right, so this is the average rate of change of cosecant x from pi over 6 to pi over 4. All right, you can click on the next to advance to problem number 10 or go to main if you want to access all the problems for the test. And don't forget to subscribe for updates to other cool tutorials such as this.